Algebra 1, Lesson 1.5, Rewriting Equations and Formulas. The essential question is, how can you use a formula for one measurement to write a formula for a different measurement? Key vocabulary. An equation that has two or more variables is called a literal equation. To rewrite a literal equation, solve for one variable in terms of the other variable or variables. Example 1, rewriting an equation. So we're solving for the equation 2y plus 5x equals 6, and we're trying to get y alone. So in this equation, you will first need to subtract 5x from each side to ensure that it's only 2y on one side. Then after you do that, you need to divide 2 from each side to get y alone. The result should end up as y equals 3 minus 5 over 2x. Example 2, rewriting a formula. The formula for the surface area S of a cone is S equals pi r squared plus pi L. Solve the formula for the slant height L. So first, we'll write out the equation. S equals pi r squared plus pi r L. We're trying to isolate the L variable. Therefore, you need to subtract pi r squared from each side. That will leave you with S minus pi r squared equals pi r L. After, you need to divide pi r from each side to make sure L is alone. The result should be S minus pi r squared over pi r equals L. A formula for converting from degrees Fahrenheit F to degrees Celsius C is Celsius equals 5/9 parentheses Fahrenheit minus 32 closing parentheses. Example 3, rewriting the temperature formula. Solve the temperature formula for Fahrenheit. So first you gotta write out the temperature formula. Celsius equals 5/9 parentheses F minus 32 parentheses. You need to find the reciprocal of the 5/9 and multiply it to both sides to get rid of the 5/9s from the Fahrenheit side. This will leave you with 9/5C equals Fahrenheit minus 32. Then you will need to undo the subtraction by adding 32 to each side. This will leave you with Fahrenheit equals 32 plus 9/5C, which is what you're looking for, as the F is isolated. So the previous 3 examples were rewriting the equation so you can isolate one variable, but these cannot be applied to real-life applications. The rewriting the variables make you end with 2 variables, one on each side. However, with real-life application, we are looking to find an actual digit. So example 4 is real-life application, and we're trying to find out which has a greater temperature, the sun or lightning. So first, we have the sun in Fahrenheit, but we have lightning in Celsius, and we need to convert lightning into Fahrenheit. So we set up the equation that we found in the previous example, F equals 9/5C plus 32. We need to replace the Celsius number with 30,000. And then we solve. 9/5 times 30,000 equals 54,000. And then we need to add 32 to it, so it'll be 54,032. 54,032 Fahrenheit is greater than 11,000 Fahrenheit. Therefore, lightning has the greater temperature. So this is another example from a different textbook, and it's using the formulas to find the area. So first you have a rectangle lot that's 500 feet deep and an area that's 100,000 square feet, and you access for $5.50 per foot of lot frontage. So you gotta find out what is the frontage of your lot and how much you're gonna be assessed for the new water system. So in this formula for the area triangle, you gotta let width W represent the lot frontage. So A equals LW is the formula, and you gotta rewrite the formula to isolate W. So W will equal A over L. Then, since it's a real life example, you would need to replace the area with the actual digit of 100,000 and L with 500 and divide it. So the W, or the lot frontage will be 200. And if it's 550 per 200 feet, then you will put 550 over 1 times 200 feet and delete the 200 feet units, which will give you 1,100, which means the total cost for the 100,000 square feet area of lot will cost 1,100. Thank you for listening to this Algebra 1 lesson 1.5, rewriting equations and formulas. Please consider subscribing to the YouTube channel and leaving a like on this video. Thank you.